Good morning, everybody. Thanks for coming to my session. Today we're going to talk about how you can improve the performance and security of your sites and services using Fiddler. Just for a room check, how many people build HTML applications, things that run in web browsers? Great. And web services that aren't running in browsers? Okay, good number. Lots of both, so that's exciting. So my name is Eric Lawrence. I started building Fiddler in 2003, and I was working at Microsoft at the time. It was a side project. In 2012, Telerik acquired me and Fiddler, and so I worked on Fiddler for Telerik and then Progress for a few years. Now I'm an engineer on the Chrome security team, so I still use Fiddler from time to time, but it's no longer my day job. But I will fly around the world to go talk about it, so it's fun. So one nice thing about this talk is it's a little more scoped than some of the Fiddler talks I've given in the past. I'm going to talk about two scenarios that I really use Fiddler a lot for, and over time Fiddler grew to serve fairly well. The first is improving performance. And so generally speaking, making the web faster isn't any kind of rocket surgery. It's really quite simple. One of the most important things you can do in order to make your sites and services faster is simply send fewer bytes, right? Talk's over, the end. Now, in reality, there's a lot of different ways to do that. So the primary one is you can make fewer requests. And that's doing things like applying caching properly, using proper caching directives, HTTP response headers, to ensure that your content is cached. Using things, as we heard this morning in the keynote, like progressive web applications can use Service Worker to load more from the cache in the client. You can use fewer resources. So you can just decide, hey, we don't actually need this feature that nobody wants and nobody's going to touch, or we're only going to load it on demand. And then you can use techniques like sprites and concatenation to put together a lot of resources into a single response. But one of the ones that I want to spend a bunch of time talking about, because Fiddler has evolved over the years to do quite a lot with it, is compression. Now, the benefit that you get out of doing compression and otherwise reducing the number of bytes on the wire is, first, obviously, is you're improving the user experience. And so by doing fewer bytes on the wire, you're getting your application in front of the user faster. But there are some other ones that are somewhat surprising, like lowering your bandwidth bills. Now, I don't know if anybody's working on major websites that serve a lot of content, but one of the things that we first used Fiddler for at Microsoft, I worked on the clip art client service, where basically we were sending millions of pieces of clip art down to users every day. And we used Fiddler to optimize the website, and the calculation I did at the time was I think we saved about $12,000 in bandwidth a month by doing the changes that we had done. Now, smaller scale services might save less, but bandwidth is not free. And certainly in some places, bandwidth is quite expensive. Another is reducing client memory usage. So as people are using lower spec devices, they just have less memory available. And so using smaller resources can improve the situation quite a bit. And then the last one is you improve your cacheability of resources. So if your resources are smaller, they're more likely to stay in the user's cache because they're not getting pushed out by eviction algorithms because they're not as large. Now, there are a bunch of different ways to do compression on the web. The first is HTTP compression, so compressing response bodies, and that's where a lot of the focus will go. There's a feature called HTTP2 header compression. So on a lot of sites, there's a lot of redundant headers. You know, you're sending your 80-character user agent string on every single HTTP request. And HTTP2 introduces a capability that solves that by not resending those bytes. And then lastly, and there's sort of the hidden one, which is compressed file formats. So if you look at the data that's in use in the web, most of it, by bytes, is in either image formats or video formats. And neither of those formats was at all practical without compression. So pretty much all image formats have compression, and all video formats have compression. But the quality of those compressions varies quite wildly, and Fiddler can help you with this. It's worth mentioning there are two types of compression. There's lossy versus lossless. So lossy compression is things like JPEG and WebM and MP4, where you're trading off bytes for fidelity. So you're trying to create a resource which looks to a user, a human user, indistinguishable from the original or very, very close to the original at a much smaller size. And lossy compression has a lot of benefits, and you can save a lot more bytes. The problem with lossy compression from the analysis standpoint is, in many cases, it's sort of subjective. You have to say, well, does this look good enough? Whereas lossless compression is a little bit simpler. the output is exactly the same as the input post-decompression. And so it's very easy to say, hey, this smaller resource is literally identical to the original resource. We just compressed it better. And so Fiddler can help with both of these. But in a lot of times when I'm looking at compression things, I'm looking at lossless because it's not really a subjective debate. It's not like, oh, we're making this trade-off for this other trade-off. It's just literally better. Now, the compression algorithm that's in use most on the internet is deflate. So deflate is an algorithm. It's the algorithm that underlies gzip. So a lot of people have heard of gzip, but not deflate. Deflate is really the algorithm that gzip is using. It's using this encoding called limpleziv77, does Huffman encoding on top. The theoretical maximum compression of gzip or deflate is 1032 to 1. But 5x is common for the sorts of resources that you're seeing for HTML, CSS, JavaScript, etc. Deflate's everywhere. If you've got content encoding, gzip, a response, if you're using WAF font files internally, WAF fonts are using deflate. PNG files internally use deflate. If you do SVGZ files, they're using deflate. PDF and Swift both use deflate internally. Now, there's an algorithm called Zopfli for generating deflate content. Zopfli does 3 to 8% better compression than zlib, but it takes 2 to 3 orders of magnitude longer to compress. However, decompression speed is unaffected. And so if you've got resources that are using deflate today, static resources in particular, one of the things that you should look at is using Zopfli to make those resources smaller. Now, one of the things people get excited about when I talk about, oh, compression X is better than compression Y, they're like, okay, it takes longer, whatever. But on the client performance is key. And I want to make sure that decompression is not impaired. I don't want to spend time on the wire and then use the user's battery to decompress. And the answer is that in most cases, the sorts of algorithms that we talk about, the compression time is variable, but the decompression time generally is not very variable, particularly for deflate. And so if you do an awesome job with deflate, it will take the same amount of time to decompress as if you do a terrible job with deflate. And I've got the picture of a maze here because that seems unintuitive to some people. But the notion is that if you find the optimal path through this maze, it might take you longer than finding a quick and dirty path through this maze. But following those steps for that optimal path is not going to take you any longer than following the longer path. And in fact, in some cases, it might even be faster to decompress better compressed content. And that's because you're not wasting as much time doing steps that are not optimal. And so in all of these things that I'm talking about improvements, we're talking about trading off compression time for fewer bytes on wire, but we're not really talking about decompression. Office has these Office web apps. So you've got the Microsoft Office suite that's been ported to the web. And here are some numbers for the JavaScript files. You see that, hey, it's served at 171K, and if you Zopfli it, you can knock 7K off, and so forth. And so on average, you're seeing, for the Office web apps, you're seeing about 4% additional compression. Now, the thing to remember, though, is you're multiplying this by millions of users. And so this starts to become a very impactful thing. Here's the Google stuff. So the algorithm looking at, hey, the Google homepage, if you did Zopfli on it. PNG files. So PNG files are internally using deflate. So what you can do is you can take your PNG file, you can pull the data stream out of it, you can recompress it with Zopfli, you can shove that data stream back in the PNG file, and now it's a smaller PNG file. And so you can see the overall savings. Over here, you're saving about 4.8% of the overall bytes on wire for Google if you did Zopfli on all the resources. Static script in CSS, especially if you're serving it from a shared CDN, is a great target for making that trade-off because you're compressing it once as part of your build process or your publish process, and then every subsequent user is benefiting from that. So these screenshots are from Fiddler's Transformer tab, which allows you to explore different sorts of compression. So you should Zopfli everything is my general guidance. If you've got static resources, JavaScript, CSS, SVGs, icons even, WAF1 fonts, and PNG, you should Zopfli all of that stuff. Here's some examples of some of the PNG files. You can see that, in the Google logo, for instance, you can save almost 9% of byte weight or 10% of byte weight for that sprite map at the bottom by using Zopfli to recompress. Now, the benefit of using Zopfli is that literally there's no difference whatsoever in the client. You don't need a client that supports Zopfli or anything like that. It's just deflate. It's just Zopfli is spending more time to get a better outcome from that deflate algorithm. Now I say don't forget icons. Icons, Windows icons, the ICO format internally has the ability to store PNG files. And so you've got this Microsoft Office logo that was in use on one of the Microsoft web pages where the icon was 17K. And it's because it had these PNG files, these large PNG files of different size and so forth within. If you actually use Zopfli to do that deflation, you can get down to 477 bytes. So basically a huge reduction in the size of that icon file. How do you do Zopfli? There's a Zopfli.exe. You just run your SVGZ through it. With PNGs, there's a tool that ships with Fiddler called PNGDISTILL, which will go optimize your PNGs for you. And then if you're using popular web servers like Nginx, there's modules for doing Zopfli. Generally speaking, you want to use Zopfli in a static manner, however, because again, it is 2 to 3 orders of magnitude slower than doing just a simple zlib. You should always do minifications first before doing compression, so still run your JavaScript minifiers and stuff. It's more effective that way. You'll get smaller output. Now, Zopfli was interesting, but Zopfli had a very severe limitation, and that was it was designed to work with all existing decoders. Well, what if we kicked those shackles off? What if we found a way to use a new decoder that was more efficient? And so a Google team who works on compression addressed this problem with an algorithm called Brotli. Brotli uses some of the same concepts as deflate, but it introduced some new characteristics around how it does compression that require a new decompressor. But the benefit is large. So on average, you're going to look at 15 to 20% improvement over gzip for the textual formats that are in use in the web today. For WAF2 fonts, WAF2 internally uses Brotli compression, and it's 30% smaller than WAF1. Serving Brotli requires HTTPS. The reason is that HTTP middle boxes very often will corrupt unknown content encodings, and Brotli is a new content encoding. So the requirement is that in order to serve Brotli content, with the exception of WAF font files, which use Brotli internally, if you want to use HTTP content encoding Brotli, you have to have an HTTPS connection. That said, the adoption of Brotli by clients has been fairly rapid and quite broad. At this point, about 71% of deployed clients support Brotli, and you've got support across Edge, Firefox, Chrome, Safari's latest versions, Opera, basically all over the place. And so Brotli is a great improvement. Clients negotiate compression. So the client sends an accept encoding header, and the server responds with a content encoding header saying which version of the compression was used. And so Brotli is an option. An example, common CSS thing, bootstrap min CSS. It's 25K served. If you use Zopfli instead, it's 18K, so you're getting 28% smaller. And if you're using Brotli, it's 16K, so it's 36% smaller. New formats and scenarios benefit heavily from Brotli, however. So have you guys heard of WebAssembly? WebAssembly is this idea of you can take traditional C++ or other types of code and compile it down to a binary format that's a restricted subset of JavaScript, et cetera, runs in client browsers. If you're building like 3D games and things that are intended to compete against native applications, WebAssembly is a hot new technology. But Brotli works very well for WebAssembly files. So we've got this WebAssembly Zen Garden demo. It has a 235 megabyte data file that sort of is the entire game / demo thing. It's served at 90 megabytes. However, if you use Brotli, it's 75 megabytes. So every single user who visits this WebAssembly thing is saving 15 megabytes. It's 17% smaller. 15 megabytes times any non-trivial number of users is quite a lot of bandwidth. Caveat here is that's with Brotli set to 11. So Brotli goes to 11, good joke. But 11 is the highest compression. And in fact, doing this 235 megabyte compression down to 75 megabytes took about 20 minutes on my laptop CPU. On a desktop CPU, it would take considerably less. But if you have Brotli set all the way up to the highest quality for huge resources, obviously you're going to do it once. You're just going to do it once and cache it on the server. Brotli, however, unlike Zopfli, is suitable for real-time compression of data, streaming compression. You might not always use it at quality 11. You might use it at quality 6 or 7. But the performance cost on compression is orders of magnitude faster than Zopfli, and it's on par with Deflate. And so in general, we're starting to see sites, CDNs and other sites, start to do real-time compression with Brotli. And so Facebook, for instance, is using Brotli for the Facebook homepage feed, things like that. And there are dynamic scenarios that it's being used for. But again, static scenarios, you can kick the compression up to 11 and save. The screenshot is another demo which saves multiple megabytes of data. So just taking a quick look through Fiddler. Let's start Fiddler. So let's go to DevReach.com. So we're loading up our thing. We get this little loading icon that Christian was complaining about. All right, so we've got some resources coming in through here. As it turns out, almost everything was in my cache. So we got our first message. The best request is the request that's never made. And so, in fact, let's go clear the thing and let's restart this in incognito, devreach.com, so that and let's turn on capturing so we're actually getting anything. Okay, so we've got a bunch of resources in here. The primary way that you're going to interact with compression in Fiddler is you're going to look at the transformer tab. So the transformer tab will tell you what it's being compressed with today and allow you to flip between things like say, okay, well, it's 6,100 bytes with gzip. If we use Zopfli, it's 5961. So small savings, not terribly interesting. So the transformer allows you to do things like say, hey, well, what if I use Brotli instead? Okay, it's 5451, so that's a non-trivial improvement. And so the transformer is sort of the simple way to get this. Now, one of the problems that arose when using that is that it's on a one-off resource basis. It's kind of annoying to have to do that one by one, how much bigger or smaller. I mean, really what you should just do is see whether or not you're using Brotli and then just go fix it and not really worry too much about the details, but some people want a business case. So let's reload the DevReach site. So one of the tools that's an extension to Fiddler, you can install it, is creates this compressibility tab. Now, what compressibility is it's just this new little tab in Fiddler, and you can take your resources, and you can go drag them over into the compressibility tab, and you can then push the button that says Recompute Compressibility. And what this extension does is it goes through every resource that you've dropped there and tries to find sort of the optimal representation of that resource. And so if we look at the homepage, for instance, the DevReach homepage, by default is 188K, but it's served with gzip down at 28K. If we just did a naive gzip using zlib, we can get it to 23K. If we use Zopfli, we can get it to 22K. And if we use Brotli, we can go to 17.5K. And so it does this for every resource within your corpus. And then what you can do, you'll see that the ones in red are things that didn't compress well. The things that didn't compress well are the WAF fonts. The reason they don't compress well is because they're already compressed. But if we select the resources, we can see what our overall, we're actually still running the comparison on some of these resources. We're recompressing all the PNG files in the Google Maps, so that's what's filling in here at the bottom. But you can see the overall savings from optimal compression. So if we move to Zopfli, we could save about 3%, about 100K, not terribly great. If we move to Brotli, we can save more than that. So we can save an additional 81K beyond that, so another 3.2%. And here's the key one. If we changed our graphics over to use WebP rather than PNGs, we would get exactly the same pixel results from our output, but we would save more than a megabyte. And so it's sort of ironic that most of these PNGs in this case are coming from Google. Google invented WebP. We're loading in Chrome. They're sending PNGs. Not awesome. But we're starting to use more technologies. Brotli is one that's being rolled out more broadly across Google. Now, when talking about compression, I like talking about text compression because it's easy and simple. But the reality is, if you look at the web, most of the web is images. And if you look at the formats, they're actually pretty widely split. This data might be a year or two out of date at this point, but PNG, JPEG, and GIF are pretty much everything. Now, one of the pieces of advice I can give you is use appropriate formats. And a simple heuristic for a lot of this is the appropriate format is never GIF. The reason is that GIF, unless it's animated, offers essentially no improvement over PNG in almost any scenario. And so here's an example of the IETF graphic on their homepage. It's just 17.8K as a GIF file. If they served it as a PNG file, it would be 5K. And if they optimize that PNG file, it would be 4K. So this image here on the left is Fiddler's Image Quality Explorer. And so let's take a quick look at that. Let's go find Eric Lawrence. Oh, that's a reasonable. Let's do this Sophia.jpg. So in Fiddler's ImageView, we right-click and we can choose Tools, and we can do Explore Quality. And so we have this JPEG file here. And what you can do is basically drag the slider left until you find a level of quality you're not happy with and say, OK, well, we're not going to go that low. And so we don't want a JPEG of quality 3 because that's pretty unusable. But as we start to get up into JPEG quality like 40 and 52 and so forth, it actually becomes sort of this credible, believable, like, yeah, we could actually serve that. We could save 50% of our bytes with a graphic that's just simply better compressed. Even in the same format. We're not even going to WebP here. We're just saying, hey, we're going to tune and tweak our compression level and use that. In some cases, you will see, like in this one here, we actually dragged it all the way over and said, hey, what if instead of a JPEG, we used a PNG file? This is almost never the right thing to do because PNG is lossless. And if you're converting a lossy image into a lossless image, you're almost certainly on the wrong side of history. However, there have been cases where JPEGs are so poorly encoded that PNG files are actually smaller. The other thing is that lossless compression like PNG is something you typically want to use for like screenshots so that you're not corrupting your fonts. Here's an example. There's this photo. This was part of the docs.com. It was a 1.2 megabyte JPEG of these guys that are just sitting around being office workers. If you compressed it with JPEG, it's 141K, visually indistinguishable to human. Now there are some new formats, JPEG XR and WebP, that are supported by modern clients. Fiddler supports these formats in most places. WebP is Google's efficient new lossless image format. Christian mentioned it briefly in the keynote this morning. Basically, it uses some of the principles behind Google's WebM encoder for doing smaller images. It's both lossy, so you can do JPEG to WebP and have lossy WebP, or you can do lossless WebP, where it's like a PNG, just smaller. And then there's JPEG XR, which is Microsoft's efficient new JPEG variant. I don't think that JPEG XR is supported outside of Internet Explorer and Edge at this point. WebP, I think, is supported by, it's supported by the Chromium family of browsers, and there are patches for Firefox, but I think they're still not landed after several years of floating around. So both of these formats are usually used on a targeted basis. So if you've got like a picture with a source set, you might do it. They're usually used for like responsive image type scenarios. But Fiddler understands these, and it can show them in the image view, the gallery, custom columns, et cetera. It parses the formats. Image analysis. So Fiddler will take a look at images and tell you as much as it can about them. It'll tell you in JPEG whether you're using progressive, whether you've got chroma subsampling set, whether there's any EXIF data, comments, metadata, et cetera. So just a quick take a look at that. So somewhere in here, let's do a little quick search for Todd. All right, so we've got Todd Anglin here, and we've got this picture of Todd, and it's a JPEG. It's 78K, 200 by 200. It's using about 2 bytes a pixel, which is not terrible. But you can see that there's actually all this metadata in here. So this is, we know that this picture was taken at Telerik Next 2015. There's some copyright info. That's all goodness. But then you start to get into things like, well, there's a thumbnail inside of this picture of Todd. And so you can actually extract that thumbnail. And so there's a picture of Todd inside the picture of Todd. It's actually almost indistinguishable. It's a pretty good thumbnail. But it's entirely unnecessary. Web browsers don't do anything useful with this information whatsoever. And so before you serve images, you want to make sure what you're serving is really what you need to be serving. So let's do a little tool on this, and let's go say, hey, what if we go to WebP lossy? So if we convert this 78K image, we can get down to, well, that seems almost unbelievable, doesn't it? 830. So, you know, almost a tenth of the size. Let's see if it's any good. Yeah, it's pretty good. I mean, there's maybe a little bit of distortion, like the very tip of his microphone is not visible anymore in the WebP for 1/10 of the byte size. So maybe we would want to go lossless on that or choose a slightly higher quality level. But Fiddler will help you find this metadata. Does the same thing for PNG and GIF. I like this one just because it's vaguely funny. So you guys know John McAfee? He like created McAfee antivirus, and then he was like on the run after like, I don't know, his neighbor got murdered or something, and he was had an interview from an undisclosed location, and he let the interviewer take his photo with an iPhone for the article, and so they published this article of like exclusive on the run with John McAfee, and then people loaded the image into Image Analyzer, and they found the EXIF data containing the geolocation of where he was hiding out. And so Fiddler, if you have an image that has geolocation embedded in it, you get this little find on map thing at the top left of the image view, and then you can click it and go to Google Maps or Bing Maps and see where that image was taken. That may or may not be relevant to you. I also can't spell geoloc, oops. The tools that are shown here are extensible. So Fiddler includes a few on the context menu by default, but you can plug in your own. Now, finding bloat like that manually is annoying. So I wrote a plugin that will find metadata bloat for you. It's called Show Image Bloat. I'm great at naming things. It's available as a download off the Fiddler download page. Basically, you just click Tools, Show Image Bloat. And what this does is, as images flow through Fiddler, it rewrites them into images that have a little brick wall based on how much bloat is in the image. And the reasoning is that designers are most of the time the folks that are creating graphics. Designers are very often not optimizing their images because they don't understand the importance of it. If you mess up a designer's image, they start to care deeply. And so what you do with this extension is you turn it on, you load your page, and then you send the page of brick walls to your designer and say, oh my God, our page is broken. And they're like, well, what is this? And then you say, well, when you saved to web in the Photoshop, you didn't choose the save to web option that drops all the metadata, and so we're sending all this metadata, and it's horrible. And they're like, oh, I definitely see that there's a problem. Whereas if you just give them the numbers, they're like, nerd, 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 I don't care. So this actually turns out to work quite well. This used to be a really fun demo when I first came out with this feature, I think it was 2 years ago. Now it's a lot less fun because most sites have cleaned up their act, at least public sites. Smaller sites, the less important the site is, typically the less cleanup has been done. So if you go to the Bulgarian government site, there are a couple images that are like more than 50% bloat, but like the DevReach site is not too bad. Microsoft used to be a horrible offender, and they've gotten way better. There used to be, when you logged into Hotmail, the background of the page was like this 1.3 megabyte JPEG file, and of the JPEG file, 80K of it was a picture, and the rest of it was Adobe editing metadata. They probably loaded this page like, I don't know, 20 or 30 million times a day. So definitely serious opportunities for improvement. The primary culprit in all of this is the Adobe Creative Suite because it uses metadata quite a lot, and so it's kind of not surprising that the Adobe website has it. But here's some more examples. Ads are another place that we often see non-optimal images. If you're building ads, you really should optimize your image because your best opportunity to get the user to click on your ad is if they can see it quickly. So how do you fix this? Well, one of the things that you can do to fix it in Fiddler is on a PNG file, you can just right-click and choose Tools and choose PNGDISTILL. What PNGDISTILL will do is it will drop all the unnecessary metadata out of the image and it will recompress the stream inside with Zopfli. And you can run PNGDISTILL in batch mode if you want, so you can convert your entire website at one time, or you can do it individually through the Fiddler UI, but it's very simple to use, and it's reliable. This isn't like changing your compression. You don't have to go manually look through your results and say, oh, that one looks okay. They'll all look exactly the same. Microsoft ran a variant of this on their source tree in Windows not so long ago when someone pointed out that there was like 5 megs of Adobe metadata bloat within the UI itself. This is an older one. Google redid their image, so you don't save quite as much anymore, but we showed the compressibility tab. That's a plugin. All right, so after we got our Office Online website working quickly and performantly, the next concern that I had was security. So I was the security program manager for the Office website. And one of the things that was super interesting about Fiddler was that it allowed you to see things that previously sort of went hidden. So before I built Fiddler, back in 2002, I went to a tech talk in the company. And there was a guy there that mentioned, oh, most of the shopping carts on the web pass prices around in hidden form fields. And you can just edit those hidden form fields and pay whatever you want. And I thought, that can't possibly be true. But I was writing extensions for Internet Explorer at the time, so I wrote this thing called Tamper.IE. And what Tamper.IE would do is every time you posted a form on the internet, it would pop up a box and show you the hidden form fields and say, anything you want to touch? And I found out it's true, actually, at the time. Most of the sites had problems like this. The only one I actually personally exploited myself was Creative Labs. Now, Creative Labs, they were a big sound card / speaker manufacturer in the day. I don't know if they exist anymore. They didn't have this problem in their primary product page. Like their pricing was good in the primary product page. But on checkout, shipping was passed around in a hidden form field. So you could buy $30 speakers with a shipping charge of negative $28, and it would cost you $2. So I didn't actually think it was going to be vulnerable. I inadvertently gave myself a discount, and then I wrote a letter to them and said, no, please charge me the right value. By the way, you've got the security bug. And they said, well, you can keep the discount. Just tell us more about the security bug. Now, this wasn't actually supposed to get out at all. But I gave a talk about this little tool at an internal conference, and then one of the people at the internal conference went off and became a professor at a university in Oregon. And so like 3 months later, I got a support email from some kid in Oregon asking about this Tamper.IE tool. I was like, oh dear. So I quickly had to go fix up a bunch of stuff to make it look less horrible and hope that I didn't get fired. But what came out of this was I knew that one of the capabilities I wanted Fiddler to have was the ability to do Tamper.IE-like things. And in fact, Fiddler does have the ability to tamper with any request or response. It can do so automatically or manually. And so let's take a quick look at that. Now, almost nobody knows about this little black box down at the bottom. It's called Quick Exec. You type commands in it. You can do searches from it. Super powerful. But we're going to invoke one of Fiddler's rules, which is BPM, which is breakpoint method. And we're going to BPM on post. We're going to start capturing. And then we're going to do Baden.com sandbox. So we're going to go to our little shopping cart example. And oh, look at these cool tablet PCs from 2003 when this was all the hotness. So I'm going to order 3 tablet PCs, and I'm going to click checkout. What that's done is it's created a form post. And if we go over into Fiddler, we can see that the data is $1,095 for these Acer convertibles, and we want 3. Well, we don't want to pay that much anymore because they're really not worth that much, so we're going to deduct the price down to $1. And then what we're going to do is we're just going to run to completion. So what this does is it modifies the data that was sent out to the website, changes the price down to $1, and hooray, you've ordered 3 convertible PCs for $1 each, and you're going to spend $3. Now, on one hand, this is ridiculously contrived. And on the other hand, no, actually, this works for a tremendous number of things, even to this day. You're not going to be able to do this to Amazon, but you would be surprised at the number of things that you can do this to. You can change both the requests and the responses. This is meaningful because if you have a client application and the client application trusts the data that it gets from the server, you're going to have a problem. Now, in some cases, it's cheating. if you're using HTTPS between the client and the server, then in theory you're okay, because unless the user installs a root certificate, they can't use Fiddler, or no other man in the middle can modify the data. The problem is if the user is your adversary. So let's say, for instance, you're an online gaming company and you make games for a popular social network for, I don't know, users get little farms of some sort and users buy power-up upgrades. Well, it turns out that you can't trust that the data, even though you're using HTTPS, you can't trust the user, because the user can use something like Fiddler or a similar tool and change the data that's coming back into the client. And so instead of one upgrade, now they have 10 or 100 or 1,000. And this actually happens. So using breakpoint debugging is a pretty powerful way of exploring through your application and seeing what's subject to manipulation. That being said, doing modifications like this manually is generally a hassle, and it doesn't scale pretty well. There's actually quite a lot of videos on YouTube of Fiddler where there's like Japanese techno punk in the background, and then like you see these people doing these various hacks for games I've never heard of. But it doesn't scale as well as doing things automatically. So Fiddler has a full extensibility system for extensions and scripts. So you can distribute your hacks, and people do. There are extensions for evaluating security for Fiddler. One of them is a content security policy generator. So you load your site, you go around, you use your site, and then from it, it will generate a content security policy that says, these are the things that it's legitimate for my site to be doing, and don't run any script that's coming from places where script isn't supposed to be coming from. Now you've got powerful protection against cross-site scripting. There's a tool called Watcher, which is from a professional pen test company, that you just surf your site and it flags potential security vulnerabilities to you. Oops, you forgot to set a character set on this page. Oops, you're leaking this piece of data in this place. It's very powerful. X5S is a different version of that. There's a fuzzer called Intruder21. So if you use tools like Burp Proxy that have fuzzing modules, Intruder21 is the fuzzing module for Fiddler. And then there's a commercial package called Ammonite, which is a plugin for Fiddler that does SQL injection and other types of things. I already did the demo. Visualization of security information. So there are all these headers for making your sites more secure. There's X-frame options, content security policy, strict transport security, access control, allow origin. There's all this stuff. Well, Fiddler makes it really easy to find all this stuff now. You just right-click, choose Customize Columns, pick Miscellaneous, pick Security Headers, click Add. We want a title. Security Headers. All right. Apparently, I already had that column, which is the problem. Let's go reload my DevReach archive, and we'll see whether or not any headers, yes. So you can start to see, like, oh, it's got a content security policy, but it does have an access control allow origin of star, which is kind of interesting. It's got XSS protection turned off, and it's got no sniff turned on. So you can see, sort of at a glance, where you're missing security headers and where they're present. If there is an illegal directive, Fiddler will include an exclamation mark in the column and say, like, basically, hey, there's an illegal directive. If you didn't know you could do this already, you can right-click and you can choose Search this column, and it will find things that where the data is just in that column. And it turns out that no web sessions match this. But if we wanted to search and find everything that had, for instance, an access control allow origin of star, we can do that, and it's going to select all of those. And so I can say, OK, these are the things I want to go look at or whatever. So Fiddler is really powerful for pulling together information about security from a broad set of pages. You can look at your HTTPS handshakes. So you can look to see what ciphers your browser offered the server. You can look at what the server offered back to the client and chose. There's a plugin from a friend of mine that does certificate analysis. So if you want to do things like get your subject public key information and look at your certificate chain, look at what sites your certs are valid for, things like that, you can plug in this inspector into Fiddler and make it really easy to get that information. The public key information was more interesting back when we had this idea of what's called public key pinning, but that feature has now been executed or on its way to being executed, so it's somewhat less interesting. You can extend Fiddler everywhere. And so this is just a really simple example of what's called a cert SH lookup. So there's this online site that you give it a certificate and it will tell you things about this certificate, like where it came from and what logs it's registered in and the status of whether it's revoked or not. So it's a cool website. The problem is you have to give it the certificate. Well, how do you get the certificate? Well, you can curl the page and drop it to a file, maybe run some OpenSSL tools to convert it to the right format, and then go to the page and then load it in. It's a hassle. So in Fiddler, you just write a little bit of Fiddler script. If you go to just github.com/EricLaw1979, you can see all my scripts. But basically, in a couple of lines of code, you can create a new tab in Fiddler, title it cert.info, and basically get the data, send it off to the server, get the response, and render it as HTML directly within Fiddler. And you can do this for all kinds of things. So Fiddler's extensibility is one of the primary reasons why the tool is useful and interesting. It came about not because I was tremendously forward-looking, but because I had no idea what Fiddler was going to be used for, and it seemed like the simplest way of potentially accomplishing something useful. One of the rules that I had for a long time was I had a rule that would go look at the expiration time of certificates, and if the expiration time was within 2 weeks, it would change the session color in red. And then that way I could do things like, 2 days before the Telerik certificate expired, I could go find somebody in IT and be like, by the way, our cert dies in 2 days, you're on that, right? You can do this for your sites. You can configure your rule so it only applies to your sites, and we'll ignore every other site. But the scripting model in Fiddler is very, very powerful. There's an example, again, on the gist for GitHub. You can tell Fiddler to warn you about non-secure redirects. So if you've got an HTTPS page that you click a link and it goes through HTTP on its way to a different HTTPS page, you can flag that. So you can say, oh, let's go clean that up. Otherwise, Eric Lawrence is going to mock me on Twitter, because I do. You can do a lot of different things like that. There's a feature called sub-resource integrity in the web platform. What it is you can say, hey, I want to get this script from this other CDN site, but I'm worried that I don't actually have control of that CDN site. And if a bad guy compromised that CDN site, then his JavaScript would be running in my website with my permissions and could steal all my users' data. That's horrible. So what you do with sub-resource integrity is you say, get the script from that CDN, but its SHA-256 hash has to be the following, or pretend like it didn't load. And so that's called sub-resource integrity. The problem is that it's kind of a hassle. You got to go, again, okay, we go curl the script down, then we use some weird OpenSSL command to SHA hash it, and then we base64 encode that, then we got to go update our script tags, whatever. Fiddler makes it very easy. You load your site, and then you select the sessions, and your sub-resource integrity JavaScript will go generate the script tags or the CSS tags that will work appropriately to apply sub-resource integrity for those resources. I don't know how I managed to go backwards in that. So let us go have a look at some other things that you can do. So we selected all of our resources. We're going over to our resource integrity hashes. You'll note that it's ignoring things that are not appropriate. So the home page itself, you can't use sub-resource integrity on. And so what it'll do is it will actually just skip that resource. But then the next thing is a style sheet. It sets cross-origin equals anonymous, which nobody understands. But for interesting technical reasons, you can only use sub-resource integrity when you're in cross-origin anonymous mode. And then it'll generate the integrity hashes. And if you don't care about SHA-384 or 512, you can just ignore that part and copy that over. But let's take a look at the script behind that. So let me kick up my script size and then look for resource integrity hashes. And so this is how you write. Actually, I should probably, maybe things have changed. Do you guys write Fiddler script at all? Anybody? This makes me so sad. All the power in Fiddler, all of it, is nothing compared to what you can do with a scripting engine and extensions. Incidentally, I wrote a book. So I watched some people using Fiddler, and I cried for a while. And I said, wow, I'm a bad person. And so I felt like it was my moral obligation to explain Fiddler to the world. And so I wrote a book. It was really hard to write the book because I'd be like, oh, here's this topic nobody understands. Let me go write 5 pages on that. And I write 5 pages on it. And I'd be like, you know, there should just be a button that does this. So then I go code the button, and then I go delete my 5 pages. Nevertheless, I still ended up with a 330-page book. So Fiddler still has plenty of complexity. But the book does cover scripting and extensions for Fiddler. So if you want to dramatically power up your Fiddler game, extensions and scripting is definitely the way to go. And I have a discount code for the ebook if you want. And then I'm going to take a couple questions and give out 3 copies of the book. But in any case, you should write scripts. It's super easy. It's JavaScript, or now there's C#. So Fiddler script originally was a JavaScript.NET thing. I don't know if people know about JavaScript.NET, but Microsoft had this .NET mutated version of JavaScript that was kind of like C# and kind of like F#, but really just JavaScript. There was almost no documentation on it. And in a fit of not smartness, I chose it as the baseline language for Fiddler. But now, in the new versions of Fiddler, there's C# script. So if you're a .NET programmer, you may want to choose that instead. But all of my examples here are in JavaScript. So it's super simple. You say, hey, I want to create a new tab. I want it to have the name resource integrity hashes. I want it to have a couple of parameters, like I don't want anything to wrap, and I don't want anything to be automatically hyperlinked. And then I'm just going to go through all of the sessions that are handed to me and say, hey, if it doesn't have a response, I can't calculate a hash on that response. If the response wasn't a 200, I'm not going to calculate a hash on the response. I'm going to look to see whether the MIME type is script or CSS, and if it's not, I'm going to skip it. And then if it is, I'm just going to get the response body hash as base64. I really tried to make this stuff easy. And so there are methods that allow you to get the data out, and then as a result, you end up with a string, and you return the string from your function, and the contents of that string become the contents of this tab. And so it's super easy to do those sorts of things. There are other powerful things that you can do with Fiddler, however. So how many people build mobile apps? Anybody? Couple? I thought mobile was like the hot thing. No mobile? OK. Well, I'll mention it anyway. So one of the key aspects about how Fiddler does HTTPS interception is it generates self-signed certificates and re-signs the traffic using those self-signed certificates. Now, normally, in a well-written application, well-written platform, the client's going to reject those and say, nice try, but no. The certificate is not from a trusted certificate authority, and so you have to install the trusted certificate on the device or the platform. Fiddler makes it really easy in Windows to automatically trust it across Windows. But on mobile devices, you usually have to visit a special page and download the cert. Well, one of the things that we've found with mobile applications in particular, and sometimes in services, things written in Java, things that are sort of have a different security posture than we might like, is you don't have to trust the Fiddler root certificate. Because it turns out they don't really validate certificates at all. If you're not validating certificates at all, you're not really doing HTTPS. And in the US, at least, quite a number of companies have faced significant fines from the Federal Trade Commission because they actually failed to turn on certificate validation. So you thought your data was being privately exchanged with your bank or your dating service or whatever, but in reality, any man in the middle could just take that data and intercept it. But Fiddler, by generating these certificates, one, you can find problems in clients that don't validate certificates at all. But two, you can also simulate a variety of conditions. Like you can tell Fiddler to generate certificates that have expired dates. And you can see whether or not your client cares whether or not the certificate is within a valid time frame. You can tell Fiddler to generate certificates for a different host name. So like you're connecting to data.example.com, but you can have it get back a certificate for evilbadguy.com. And there are platforms that fail to validate that the certificate it got back is for the site it was supposed to be. And so you can use Fiddler. Oops, my breakpoint method rule in the background has observed that somebody is trying to post data somewhere. You can use Fiddler to generate invalid certificates and see whether or not your client accepts them. Now I told you how to turn on breakpoint rules, but I didn't tell you how to turn them off. That was kind of rude. So first off, you can type G and it will go on all paused requests, or alternatively, you can just click go in the toolbar. But to disable the breakpoint, you can do BPM with no text after it, and it will breakpoint and turn off those breakpoints. You can also do BPU for breakpoint URL. You can do, I think there's one for the content type of the response and so forth. But there's quite a lot of flexibility and power in the HTTPS interceptions features of Fiddler. To do a rule, so like this is all super easy. Like if you do nothing else out of this talk, just click rules, customize rules, and look through the file, because it's super, super straightforward. So one of the things you could do here, we've got this, let's create a rule that says if osession.hostname is example.com, coding live is not a good idea for me. We're going to do osession x override subject cn equals foo.com. And you know what? I don't think it's override subject. I think it's override cert cn. So now we get to see how well I remember Fiddler after not working on it for a few years. So https example.com. Please be right. Oh, look. It says the server foo.com presented a certificate that did not validate because it was just issued for a different host. And so I'm going to proceed. Now you see Chrome actually cares that this certificate matches. And it's going to say, hey, your connection is not private, common name invalid. If we go into the advanced, we say, you see the server says it's example.com, but its security certificate is from foo.com. This may indicate that you're being man-in-the-middle, which in fact you are. But so you can use features like this to test whether or not your client is properly validating the HTTPS interceptions, HTTPS connections, avoiding interception. You can do other things. You can look at every response body and look to see whether or not there's something problematic in that response body. So for instance, if you've got some sort of like internal error strings that might be leaking out into pages, you can have Fiddler look at every HTTP response and flag it in red if it ever sees this, or post something to monitoring. You can run rules to retarget your traffic. So if you've got a dev and a production site, or you can do funny things like this, where if you try to go to google.com, you'll instead go to my website. It turns out that for HTTPS, that doesn't work terribly well, but other than that, it's kind of interesting. OK, well, I believe that I have nothing else to talk about. Oops. Grr, PowerPoint. So I do have a few things to mention. First, there's a survey. Please fill it out. I don't know what happens if you do or do not, but it would be great if you filled it out and let them know whether or not this is the sort of thing you're looking for. I'll also mention there's a ebook. Ebook is normally $15. It's been on perpetual sale for $10 because I'm lazy. But for this conference, I'm doing a deal where it's like $4.95. So if you want the ebook, it's 330 pages. It is essentially the electronic version of this. This is basically everything there is to know about Fiddler in long prose format. I'm hoping that at least a few of you have questions about interesting performance or security things that you can do. And to entice you to ask such questions, the first 3 askers of questions will get a copy of the book. Anybody? Come on. Yes? So how do I change forms with scripts? So there are a couple of different ways to do it, depending on what you'd like to do in terms of your scripting. If you'd like to just look for, say, hidden form fields, what you would do is you'd write a rule that says inside your onBefore response handler, down here, you would basically write a rule that says you've got var o or s equals o session dot get response body as string, and then you do like basically you'd create a regular expression that looks for a form tag. Maybe you look for a hidden input. And then you could do things like either inject a new form field or inject a value in that form field. The kids that are cheating on games, the way they usually do it is they look for outbound URL request parameters, and then they increment the numbers on the request parameters, things like that. So depending on what you're trying to do, like if you're trying to add a form field, the first thing in almost anything is targeting. You want to find the request that you're looking for, whether it's by the URL, by the content type of the response. Obviously, the content type of the response is only available when the response is available. The URL is available at all times. One of the things I would suggest is that if you're trying to make sure when you write your rules, one of the most common things people do is they have the wrong matching criteria. So URLs are case sensitive, for instance, and so they might have not remembered that, and they typed in the o session URL, it's URI contains, like you do foo.bar. So what you do is you say like, hey, if that, you do your logic, but one of the things that you should do in addition to your logic is you should set a background color. So you do o session UI color equals red. And then before you send email to support complaining that Fiddler's trash and doesn't work, you make sure that the URL in your session list is red, because if it's not, you actually didn't match your request, and that's why your modification isn't working. And so that would be the primary way is find the response body, and then you can use regular expressions to modify the form. If you want to come down and give you a look. Anybody else? Back in there in the corner?
What's the difference between Fiddler and Burp Suite? For example, why should I use Fiddler instead of Burp?
Right. So what's the difference between Fiddler and Burp? Why should I use Fiddler instead of Burp? So the short answer is it kind of depends on what you're trying to do. I am not an expert on Burp Suite. I have not looked at it in probably 5 to 10 years. Burp is another interception proxy. It's available. It runs in Java. It runs on multiple platforms. It's cool. It's very interesting for penetration test type things. Its extensibility model is somewhat different than Fiddler. As a .NET programmer, I always found Fiddler easier to extend than doing anything in Burp Suite. Burp Suite is definitely more targeted for things that are automated security analysis type things. So if I'm trying to do fuzzing against an interface, there are modules for Burp. The way to think about it most of the time is like if you're trying to be a hacker, Burp is probably more native to what you're trying to accomplish. Whereas Fiddler is a more general purpose tool. I can use the same tool that I use to manipulate, evaluate performance to do security penetration testing. If you want Fiddler to compete with Burp, you typically want to use plugins. And so some of the plugins available are written from people who liked using Burp but wanted the convenience and flexibility of Fiddler, so they wrote extensions to do those sorts of fuzzing tasks. But yeah, it's certainly Burp is a fine tool and is used quite a lot. I think they're free for some types of use and not free for others. But it is a tool that is mostly targeted. That being said, there are people that use Burp for more general tasks that aren't security related, but those never seem to be nearly as popular as the security related tasks.
Thanks.
I'm gonna grab somebody middle.
Hang on. It's okay.
How to prevent those attacks that you already shown when you change submit form?
So the shortest answer is you can make it harder. You can do things like ASP.NET has things like MAX, message authentications, and things like that, where you're making it more challenging for the user to just naively manipulate form fields. The problem, however, is that ultimately the client has all of the information. The client, if you have a secret key, the client needs the secret key in order to compute the hash and regenerate that data. So a sufficiently advanced user is going to just go find your thing, recalculate your hash, and put it back in the page. Ultimately, what it comes down to is you just can't ever trust the client. Now, there are some exemptions to this. If you're building a mobile application in particular, most mobile app platforms have this notion of key pinning. With key pinning, what it is you say, hey, I don't want just any certificate for DevReach.com. I want exactly this certificate for DevReach.com. And if I don't get it, hang up. Banks commonly do this. Apple does it with iTunes and things like that. In order for Fiddler to intercept HTTPS connections that are using key pinning, you have to jailbreak the device and turn off key pinning in the platform layer. If you have a high-value service, people will do this. If you have Instagram, people will do this for reasons I don't understand. But key pinning is a way to make it harder for your website to get owned by Fiddler users. But generally speaking, you have to trust. You have to not trust the client. Sometimes it's just about setting limits. There's this game called Pirates Love Daisies. It was this really popular HTML5, look at how powerful the platform game is. And so naturally upon playing it, I played it for 30 seconds and then said, okay, obviously I want the highest score, so let's go in Fiddler and set myself the highest score. And so you send yourself 1 billion points and then you submit the post to the server and it says, nice try. I know you can't get 1 billion points. And I in particular know you can't get 1 billion points in a game that we pinged to the server less than 5 seconds ago that the game started. And now less than 5 seconds later, you say you have 1 billion points. I know it's not physically possible to get that. So you have to have data validation on the server side that looks at whether or not the data is plausible. But generally speaking, yes, the message should be you can never trust the client. That doesn't mean you shouldn't use HTTPS, because in order for Fiddler to work, the client has to be hostile. The client has to put the certificate in its own store. If you don't use HTTPS, any bad guy on the network can do this and will do this, but you can just never trust the client. So that was 3. I am now at the end of my time. I'm happy to answer further questions if folks want to come down.
Thank you.
But I think it's lunchtime, so I imagine there's going to be like this cloud of dust as everyone disappears. Bye.